Good afternoon, West Marvels. This is Mr. Tashima. I'm sending you this video because I am going to work through one of the homework problems. Practice letter A, h of x equals the sine of pi x minus 3. This is my second take at this. I already started a little bit, but the lights went off in my classroom, and so I'm starting again. In the event that happens, just ignore it, and the lights will come back on as soon as I cause the motion sensor to recognize that I'm still here. So my first step was to recopy the problem, and when I recopied the problem, h of x equals the sine of pi x minus 3, I also went ahead and labeled any parts of the transformation that we knew. So right now I know that the parent function is sine of x. I also know this is continuing to be a positive sine of x graph, and I labeled my a term as a 1. It wasn't written in there, but I added it. My b term is pi, and the m term is negative 3. From there, I can now begin to work on my map characteristics. Remember, map stands for midline. This is the middle line of the function. The a is the amplitude. The p stands for period, and s is going to be the scale that we use on our final x and y axis when we draw this transformation. My midline I already identified as y equals negative 3 because the m term, which is the same as what the k term used to be, is going to cause a shift of the parent function down 3 units, which is going to cause the new midline to be y equals negative 3. My amplitude, like I said, is 1 because there's no other number written in front of the sine function, so I know that there's an imaginary 1 there. And because the amplitude is 1, I now also have enough information to identify what the maximum and minimum values of this graph will be. The maximum of this graph is going to be m plus a, so negative 3 plus 1 is going to take me up to negative 2, and the minimum will be the midline minus the amplitude, negative 3 minus 1, which is negative 4. Now I'm also able to tell you about the period. Remember, there's a simple formula for finding the period of the function. We start with 2 pi because that's the period of the parent function, and then we divide by b. In this example, I can replace b with pi because I've identified pi as my b term. And when I do that division, 2 pi divided by pi, and simplify, I get that my period is 2. It is possible to have a period of 2. Lately, our period has all been in terms of pi, but it's also possible to have whole numbers as a period, or any other number for that matter as well. The last step is to figure out what my scale is going to be, and to find the scale that I'll use on my x and y, on my x-axis, it will be found by taking the period and dividing by 4. So in this case, my period is 2 divided by 4, and that is equal to 1/2. So before I've drawn anything, I now know that my midline is going to be at negative 3, my maximum is negative 2, and my minimum is negative 4. Based on this data, is this sine function ever going to cross the x-axis? I hope you said no, because the maximum height of this function is going to be negative 2, which is well below the x-axis, so it will never cross the x-axis. When I get ready to draw my transformation, I'm going to start with an x and y axis, and I am going to begin actually by mapping in my midline. My midline is negative 3, so I'm going to go to negative 3 on the y-axis, and I'm actually going to add in a dotted line that just helps me as a guideline know that that's going to be my midline, and it's fine to label it as the midline. I'm also going to take this opportunity to add a dotted line in at my maximum. The maximum is going to be at negative 2, so I'm going to add a dashed line at y equals negative 2, just so I remember that that's the maximum value possible on my graph, and as well at negative 4 as my minimum. And just like I asked before, I can see that this graph I know will be the periodic function will be between these maximum min. It's never going to cross the x-axis. It would be great if I could start drawing now, but I do not have any guidelines along my x-axis to know my period or know what my scale is. So I go back over here and I see that the scale was 1/2. So when I add marks to my x-axis, I'm going to go by a scale of 1/2, meaning the first will be 1/2, and I'll continue to add a half to each one. So the next would be 1, and then I'm going to have 1.5, 2, 2.5, 3, and I can copy this also in the negative direction, -1/2, -1, -1.5, -2, -2.5, -3. If you had decided to put 0.5 and 1 and 1.5, that would also be correct. Both are fine. So I have used my midline, I've used the amplitude, and I've used the scale. What I have not yet used is the period, or checked the period, to make sure that my final graph is correct. But I'm ready to start plotting in points. And now that I'm ready to start plotting in points, I need to figure out if I am drawing a sine or a cosine graph. And I go back to the original equation to see I'm drawing a sine graph. Just for my own memory, I'm going to sketch a really simple sine graph just to make sure I remember what it looks like. Key characteristics of the sine graph: it passes through the origin. It's going to start at the midpoint of, or the midline of this parent function. The max is 1, the minimum is -1, and the period is 2 pi. This is what the parent sine function is, and so I'm going to use that as I get prepared to draw this transformation. Because sine starts at the midline, I know that on my graph, I'm also going to start at the midline. And because I've already worked out the scale, I can just use my scale markings to indicate the next points that I'll need to make to connect my graph to create the sine function given in the problem. So at 1/2, I'll be at the maximum. Once I'm at the maximum, I can go nowhere but back down. So at 1, I'll be back at the midline. At 1.5, I'll be at the minimum. And at 2, I'll be back at the midline. If I connect these with a gentle curve, I see that one complete period of my function is taking 2 units. And that's consistent with what I calculated the period to be at 2. So I can continue then for the rest of my graph to follow the pattern so that my function, and I could even hit that a little bit better, matches what I said it would. At this point, now I've even checked the period, and the period is 2 pi, or no, it's not 2 pi, the period is just 2. And if I check between any 2 maximums, from this point to this point, this is a total distance of 2. Any 2 minimums is a total distance of 2. And I know that I've graphed this graph correctly. If you have any other questions about this, please make sure you ask tomorrow during class. Thanks for watching.